can see the Ansys Electronics desktop, which includes different tools. In the top ribbon, you can see the list of tools available in the electronic desktop. We have HFSS for high frequency applications, and we have the HFSS 3D layout, which is a tool for the layout interface of the HFSS. We have the Q3D extractor and 2D extractor, which can be used to extract the RLCG parasitics. So you can build the equivalent circuit model of your 3D components. We have the circuit simulation tools, EMIT, which is used for co-site simulation for antenna placement, and you can see how the antennas are affecting, or RF systems on to a complete system would affect each other. We have IcePack. Ansys IcePack is a tool for electronics cooling systems. And we have Maxwell for low frequency applications, Simpler for this. This is also a circuit simulator tool, which will help you to simulate the overall system. And we have Mechanical, which is used for the stresses and so on. So here in the tabs, you can see the workflow. What you need to do, you're going to start with drawing your model. So in the ribbon, we have tools available for you to, if you can either import your 3D structure into HFSS, or you can draw your own geometry. So we have different shapes available. You can do different operations if you want to move while you are drawing your geometry. You can move, rotate, which will help you. These features will help you to easily design simple geometry. If you have complex geometry, it would be easier to import those geometry from the CAD tools such as Space, Claim, and so on. After you're done with creating your geometry, you would need to add the simulation setup. You can validate your design to make sure that the setup is completed, and then you can analyze it and the results. So this is the GUI for Ansys HFSS. So when you add a project, you can see the name of project in the project manager on the top left. You can also see the workflow that you need to follow here in the project manager. So you can start by creating the 3D geometry of your design or import it. Then you have to assign boundaries and add excitation for your input, and then you need to do the analysis setup. And if you're interested to do parametrics and optometric analysis, so you can assign variable from different aspects of your design, so you can sweep those parameters to make sure that how changing those parameters would affect the performance of your design components or overall system. Then you can check the results, and you can plot the fields. You can plot the electric field, magnetic field on to your geometry, so it's more visible. You can just see how they look. In the middle, you can see the model tree. The model tree, so where here in the middle, you can see where this is the workspace, where you will be adding your geometry and so on. So in the model tree, you would have all the information related to what you are adding into your workspace. So if you are importing the geometry, you would be able to see the file is imported, or you have created your own model. You can assign materials to different part of your 3D geometry, and from the library, we have a material library with many different materials, and if you can also customize, you can add your material if you already know the electrical properties, so you can just input those parameters and you can add your material to the material library and assign it to each part of the 3D geometry. Also in HFSS, it will allow you to create encrypted 3D components. So when you are designing a component, if you don't want to share the information inside your component, you can create that encrypted model. When you are importing an encrypted model from a manufacturer or someone who doesn't want you to see inside the model, so the software will behave that 3D encrypted component as a black box, so you can just place it into your geometry and then do the simulation and so on. For today's demo, I'm going to show you the example of the coffee pot and the ESD simulation analysis for this coffee pot. So why EMC is important? So when you are placing all these different parts of like PCBs, antennas, and so on, all of these products, they might influence each other or the environment around these products, so they might affect the performance. So here in this example, we have a coffee machine. You can rotate and turn it, so you would be able to have a better view. If you want from the model, the parts that you have designed, if you click on each, you can zoom in to see the parts. You can see here the PCBs, you can see the antennas. This is a model of the coffee pot on a table. Here we don't, we are showing the simplified model. We don't add the table. We have added only the discharge planes. We have the vertical and horizontal discharge plane, and also we have these resistors. We're touching the ground. This part shows the ESD gun, where you can see with the vertical plane. So there are different ways that we can test our machine for ESD analysis. We can have a direct discharge or indirect discharge. So here the idea is we are putting a coupling plane, then we put the discharge gun against the coupling plane, and this plane would generate the electromagnetic fields that interferes with the coffee machine. So in our design, when you are importing, you need to define some boundaries. So here we have the antennas. You can define finite conductive boundary conditions to different parts of the, depending on the design that you have. So you would decide if you need to use the boundary conditions, excitation. So here in this example, since we have antennas, we have the display board, we have, here you can see the ESD gun inputs. You can easily zoom in, zoom out. You can add the analysis setup and the run your simulation. Since this is a very complicated, large geometry and large problem, so I've done the simulation before. Let me just show you some of the results that I obtained. You can see the field strength between the PCBs. You can see the display driver areas. So for the ESD input, if you can, for your input voltage, so here we are doing the transient analysis. So for the input voltage, to model the ESD voltage, you need, you can either import the data sheet or input The numbers, you can import them manually or import it with the Excel datasheet to have the input voltage shape. Here also in the excitation, you can see the waveform, the voltage waveform that we are applying to these coffee machine to see how would be the effect of the ESD analysis. Once you're done with the simulation and you got your result, it's also possible to see the electric field on different parts. So it depends on where you want, you can see the electric field. So let me just show you. So you can see the electric field on the horizontal plane and vertical in the XZ plane or YZ plane. You can also see on the display, the coffee machine display, and also see at the connector between the display and the parts of the coffee machine. And also, when you're plotting the electric fields, when you're generating the electric field, it will allow, the software will allow you to generate animations. So it would be easier for you to see how. When you are plotting the electric field, if you just right click, you can generate animation. So here you can see so you can see when it starts from the beginning, around the 20 nanoseconds, you can see the discharge of the electric gun. You can see how would be the effects of the electric field. You can see it's maximum at around 25-30 nanoseconds. So with this, I will conclude my demo session. I would like to thank everyone for joining our session. So thank you for joining this session. Have a good day.